Morning, morning.
Morning.
Goodness, Smiles, you always here first again.
Ada first.
First to class. Smiles, that's good. But I wonder why. What happened? You get up early now. I want to help mom with the dishes or something.
Sure, sir.
Ah. All right. You ready? All right, let's see how many people. Only 17 people are in today. Kind of thing is 17 people. Wow, wow, wow. All right, we're up to 22 now. 22 people. All right, so let me begin. I'm gonna be sharing my screen so that we are able to look. The first thing we need to know about the cosine rule is that it takes a proof. So it takes a proof just like the sine rule. It's relatively lengthy, as I told you. When it comes to the sine and cosine rule, um, normally we're asked to prove those for CXC. So it is best that you learn these as best you can. So again, the cosine rule is not a right angle triangle. If you have a right angle triangle, you cannot utilize the sine nor the cosine rule. So I'm gonna call this A, I'll call this B, I'm gonna call this C. All right, so here we have a obtuse angle triangle. And what I will be doing is obviously I can't, as I said, we can't use Pythagoras nor trigonometry if it's not a right angle. So I'm going to take and I'm going to make this a right angle triangle. I'm going to extend it, right? So this is D, all right? Note one thing though, from the original triangle, this is side A, this is side B, and this is side C. You need to know this as we go along. So I'm just putting it there. Now, if we're looking at Pythagoras' theorem, let's start with what we do not have. What is imaginary? What we put there for use, for our personal use. So first I'm gonna consider triangle BCD, and I'm gonna be using Pythagoras's theorem on it, his stolen theorem. So that means that I'm gonna have that D squared is equal to C squared plus B squared. Obviously, D squared is side E. So E squared is equal to this imaginary C, which I'm gonna call BD squared, plus this side, which is imaginary B, which is CD squared. Everybody with me? Guys, are you with me?
Sure.
All right, now, the next thing I'm going to do is I'm going to consider now this right here, the whole big right angle triangle. Right? So I'm gonna say, I'm going to be using Pythagoras again. So this was, you can see this is step A. So this will be step B. So this time I'm gonna consider triangle ABD. And ABD then, using Pythagoras, because cosine rule is actually a derivative of Pythagoras' theorem, we know that the hypotenuse for this, since this is the right angle here, so the hypotenuse is AB, so AB squared is equal to BD squared plus AD squared. Now the problem with this is that AD has a real part, which is this part, and it has an imaginary part, which is the other part, which is this part right here. So that's the imaginary part and that's the real part. So I need to work that out. I need to deal with that, all right? So I will say that AB squared is equal to, well, BD squared plus AC plus CD squared, right? AC being the real part and CD being the imaginary part. Everybody with me so far? Guys?
Sir.
Yes, sir.
All right. Now that we have that into consideration, this piece right here, I'm gonna even put it in a different color. This piece right here is following a different rule. All right. So I will say that I'm gonna need to be using A plus B squared, which is A squared plus 2AB plus B squared for this part right there. Okay, which will give me then AB squared is equal to BD squared plus AC squared plus 2AC times CD plus CD squared. Everybody with me? Did I lose anybody?
Yes, sir. You lost me right there.
Uh-huh. Where
Wanna use it the AB square equals BD square.
because remember, the A is being represented by AC and the B is being represented by CD. So the A squared is the AC squared. The CD squared or the B squared is the CD squared, and the 2AB, well, the 2 is from the formula. The A is the first value, which is AC. The B is the second value, which is the CD. You with me now?
Yes, sir.
All right. Now, note that this and this, let me put 2 lines underneath each, is found right here. You notice? Yes? Because BD squared plus CD squared is A squared. So I can remove them. In fact, let's remove everything. AC is actually AB. That's C, that side C is AB. So if I say AB squared, that's like me saying C squared equals, well, I just told you that this and this gives me A squared plus, let's look at the next one, AC. Where is AC? AC is right here, see, A to C. And A to C, we call it B. So this will be B squared plus, now here's the problem, 2 AC we said is B. Now the problem is that CD is imaginary. It's the orange piece. CD is the orange piece right here. So I don't know what to do with that yet. So let me just bring it down and place it as just CD. But, so this is where C comes in. So C, if I look at this triangle, I'm gonna call this, right? I'm gonna call this 180 minus theta. I'm gonna call this one theta, okay? Are you with me? Or if you want, you can do it the other way around. It not really matter. I can call this theta. I can call this 180 minus theta. Do you see why? Talk to me. Do you see why? Yes or no?
No, sir.
How much does a straight angle have? How many degrees does a straight angle have?
180.
180.
So if this is theta, then the remainder will be 180 minus that, isn't it? Yes or no?
Yes, sir.
Yes, exactly. So now let me consider now the same triangle, BCD. This CD, I can call it the adjacent of that triangle. And A is actually the hypotenuse. So which trig ratio talks about adjacent over hypotenuse? Which trig ratio?
Cosine.
Cosine. So I'm going to be using cosine ratio. And the cosine ratio says that the cosine, oh Lord, the cosine of theta is adjacent over the hypotenuse. So that means that the cosine of theta, the adjacent is CD, right? Is CD. And the hypotenuse, we found it to be A. Yes? Everybody with me?
Yes.
But CD did not exist. So CD not exist anyata. So CD is equal to A cos of theta. No, but is this inside the triangle? Huh? Is this inside the triangle? Guys?
Yes, sir.
No, it's not inside the triangle. It is outside the triangle, isn't it? Yes or no?
Yes, sir.
Yes, it's outside the triangle. But note, something that you should always remember, guys, should always remember, is that the cosine of theta is equal to the negative cosine of 180 minus theta. So that's what we're going to be using. Okay? Using that. So that means that CD is equal to a negative A cos of 180 minus theta. Are you with me? Guys, are you with me? This is a rule.
Yes, sir.
Huh? You're not with me. I'll ask you again. Yes?
Yes, sir. With that cosine equals negative cosine minus 180 minus theta.
Because Mr. Agas, a cosine graph, right, looks like this in its entirety. Oh yeah, looks like this. The middle point is 180, all right? But this and this are symmetrical But where this is positive, this is negative. So let's say, for example, I have a value here, and this value is a half. And I have a value here where this value is negative a half, right? What this is saying is if the distance from here to here is 60, the distance from the 180 to this point will also be 60. So what is the actual value here then? What's 180 minus 60 then?
120.
120. So it is negatively symmetrical. So wherever there is half on the 0 to 90, there will be a negative half from the 90 to 180. The only difference is that you're going to have to subtract this amount that you have from over here. That is what we call supplementary. That's why supplementary is so important, because it works for both sine and it works for cosine. You with me now then, Mr.?
Yes, sir. Yes, sir. Thanks.
Right, but there's another catch. The 180 minus theta is within the triangle. It's within the triangle, and it is actually called angle
C.
C. So this is like saying negative A cosine of angle C, which means that now I can substitute. I'm going to change back my color. I can now substitute negative A cos of C for what we call CD. So it will read C squared is equal to A squared plus B squared minus 2AB cosine of the angle called C. All right? So that is the complete proof. So this is a complete proof in its entirety. Okay? So it takes basically 4 steps. So you can call this DM A, B, C, D, and this section with the substitution will be E, if that's what you want to call it. So it has 5 sections if you're gonna look at it in general.
So, sir, we didn't solve nothing, sir. We just
No, I am
Right.
proving why is it that it works. Now, when can we use the cosine rule? Well, we can use it when we have a side angle side situation, as in this case, right here, it gives you A, B, and the angle of B because we're looking for C. So we can use it in this case. And we can also use it in the case SSS when 3 sides are given. So there are 2 ways in which we can use this equation. Now, a few things that I need to mention about the cosine rule. All right. 1, you cannot transpose it for you to find another side. For example, notice we said that if I want to find C squared, I have to take A squared plus B squared minus 2AB cosine of the angle called C. Let's say I was looking for A. I cannot transpose this. I would have to just change or replace the A with C. So it would be A squared equals C squared plus B squared minus 2BC cosine of angle A. And similarly for B, it would have to be B squared is equal to A squared plus C squared minus 2AC cos of angle B. In other words, regular transposition for looking for the missing side does not work in this case. Okay? So if I'm looking for a side, I cannot take the original, which is the one that has the little X on it. I cannot take that and try to transpose it to find another side. No, I must literally replace what I want with what I have. The only time that there is a transposition is when I am looking for an angle. So whenever I am looking for an angle, that is when I will transpose. And let me show you the transposition. So let's say and it has to be from its original set. So for example, if I'm looking for angle C, as in this case, I will take C squared equal A squared plus B squared minus 2AB cos of C, and I will gather like terms, meaning this which is negative, which should not be negative, will fly to this side, and the C will come to that side, giving me 2AB cos of angle C equals A squared plus B squared minus C squared. And then I will divide both sides by 2AB. And hence I will have that the cosine of C is A squared plus B squared minus C squared over 2AB. And so this will be the transpose formula if I'm looking for angle C. Okay? Questions, guys? Questions? This is the time to ask.